The basic form of an exponential function is y equals a times b to the x power, where a and b are constants. I know that sometimes when we use letters in an equation, we're saying that's a variable. Are a and b variables this time though? No, they're specifically standing for something, and when we write our actual equation, a and b are not going to be in the equation. There's going to be numbers that stand in place of those letters. Okay? So we're trying to figure out what a and b have, what effect they have on the table. So that's where we're going. That's what our goal is. Okay? So look at problem number 1. Y equals 3 times 2 to the x power. Well, I just told you right up here in this sentence that the general form is y equals a times b to the x power. Do you have enough knowledge to tell me what a is and what b is? Yes? So someone tell me. A is 3, b is 2. How do you know that? Because you can read, okay? That's good. You know what they told me earlier? A is first. Do you agree with that? Do we agree that that's a really good definition? It is for this one, right? So for now, let's just go with it. For now. Okay? So let's figure out our table that goes along with this equation right here. Okay? So if x is 0, what's 2 to the 0 power? Okay, you're scaring me by saying 0, so let me remind you of something. Do you remember this foldable we made earlier this year? When we went on the back page, I told you that anything to the 0 power is 1. And in fact, some of you argued with me about that, because that's what you do. Okay, so I drew you an area model to represent this problem. And you all agreed with me that 2 to the first power was 2. So I drew a rectangle that had 2 boxes in it. And you all agreed with me that 2 to the second power was 4, so I drew you an area model that represented 4. 2 to the third power was 8, and 2 to the fourth power was 16, and I drew the respective area models. And I said if you're going up this list, the exponents are increasing by 1. And if you're going up the area model, these are what's happening to these. They're doubling every time, right? From 2 to 4, that's double. From 4 to 8, that's double. From 8 to 16, that's double. So I said, what if we decrease? What if we're going this direction? 4, 3, 2, 1. What would be next? 0. And I said, if we're going down this direction, how are we getting from here to here? And from here to here, and here to here? We divide it by 2, right? So I said, if we're getting to 2 to the 0 power, by subtracting one exponent, then the area model should be half as big as it was before, and half of 2 is 1. And then most of you said, oh. And some of you were like, huh. Are you better? Yes? Okay, good. Okay. Do you remember us having that conversation though? Okay, so what is 2 to the 0 power? 1. What is 1 times 3? 3. Okay, what's 2 to the first power? 2 times 3? 6. What's 2 to the second power, or 2 squared? 4 times 3? 12. What's 2 to the third power? 2 times 2 times 2. 8 times 3? 24. And 2 to the fourth power? 16 times 3? 48. Okay, so then I want to look at this side column right here. It says ratio. How do you find a ratio? What action are you taking when you're finding a ratio? What mathematical action? Other way. Dividing, right? So if I'm dividing a term, I divide the term by the term before it, right? So what is 6 divided by 3? 2. What is 12 divided by 6? 2. What's 24 divided by 12? 2. What's 48 divided by 24? 2. Now, is it good enough to just know that 6 divided by 3 is 2 and then just fill the rest in? Nope. We got to figure it out for the whole table. Now, I'm not asking for a whole bunch of values either. I'm only asking for 5 values of the table, so I'm only asking for 4 ratios. So can you just do that? Yes? Okay. Let's do number 2. Again, we're not having conversations yet. We're just thinking right now. Okay. What is the A value? So you said a second ago it's the first one, right? So 2, and then what's B? 3. Okay. So let's try to think a little smarter this time. Okay. Why don't I just do 2 times 3 and then raise that number to all these powers? Oh, I don't like that face. Can I do that? Can I multiply 2 times 3 and then raise it to the power? Absolutely not, can I? What's order of operations say? Exponents first, before multiplication, right? So can I multiply 2 times 3 and then raise it to the power? No, that's why on this problem, every single time I raise it to the power first and then multiplied by 3. Did you notice that? Good? Okay, but I wanted to make sure we had that conversation of why we didn't just multiply these together. If we try to multiply those together, I'm going to give you a sad face. That's bad. Okay? So again, though, I really want us to work smarter about this. So what I actually want us to do is I want to go to our calculator and create a graph page. Because watch what happens when I put in my equation, which is 2 times 3 raised to the x power. I can see what it looks like, yeah, for sure, but when I press Control Table, look, it's already filled in for me. Right? You proved to me on this table you know how to do it, so can we use the calculator for the rest of them? Yes, so let's do that. 0 is 2, 6, 18, 54, and 162. So what is my ratio? What is 6 divided by 2? 3. What is 18 divided by 6? 3. What is 54 divided by 18? Thank you to the one person in the room that's actually checking this with their calculator, not just assuming it's 3. What's 162 divided by 54? Okay so far? Okay, number 3. A and B. You guys keep saying that A is the first one, so A is 6. Why are you disagreeing with me?
Because the 6 is with the exponent.
Oh, the 6 is with the exponent, but you guys have been saying A is the first one. So isn't 6 the first one? It is, so do we need to maybe reword how we have this saved in our head? Okay, so what do we actually know? Which one of these is actually easier for most people to see? The B is the easier to see because why? It's with the exponent. Some people remember the B as it's the base of the exponent. B. Okay, so in this problem, B is 6. That's why in this problem B was 3, not because 2 was first, but because 3 is the base of the exponent. That's why in this problem 2 was B, because 2 is the base of the exponent. Yes? All right, so what about problem 3? We still have to figure out what A is. Okay, so those have been the 2 most popular answers today when I asked this question. It's either 0 or 1. And I really need you to know which one it is. If you multiply any number by 0, you get nothing, right? So none of this would be worth doing at all. So A is really 1. It's an understood 1. 1 times 6 to the x power is still just 6 to the x power, right? Okay, so in my calculator, I'm going to clear my table off and then go and press Tab and go up and change my equation. 6 raised to the x power. And then go to my table. I've got a 1, a 6, a 36, a 216, and a 1296. Now, it's not real hard to add a calculator page. Remember, I can just do Control Page and add a calculator. Now, hopefully I don't have to do 6 divided by 1 to figure out what the ratio is, right? On a good day, I can do 6 divided by 1. What about 36 divided by 6? Do I have to use the calculator for that? No. What about 216 divided by 36? I probably need to check that one, right? What about 1296 divided by 216? I can check that one pretty easily as well. Yes? Number 4. A and B. What you got? A is 8. Somebody else tell me B. 0.5. Go back to my calculator page. Tab to change my equation. 8.5 raised to the x. Control T for my table. 8421.5. What's 4 divided by 8? 1/2? 1/2 is what you said, right? What's 2 divided by 4? 1/2. What's 1 divided by 2? What's 0.5 divided by 1? 0.5, right? Which is the same as 1/2. This whole thing could be 1/2, couldn't it? Or 0.5, like that. Because those are the same things, aren't they? Okay. Problem number 5. A is 100. B is 0.5. So Control T, get my table. 100, 50, 25, 12.5, 6.25. 50 divided by 100, 0.5. 25 divided by 50, 0.5. 12.5 divided by 25, 6.25 divided by 12.5. What about 6? $200 is A. B is 0.8. Good job. So there's my graph. Control T to take me to my table. 200, 160, 128, 102.4, 81.92. Now, if you can do these in your head, that's great, but probably better check them with your calculator, right? 160 divided by 200, 0.8. 128 divided by 160, 0.8. Somebody have the last two yet? I see you guys working. 0.8 and 0.8. Good. Tell me what you just said a minute ago. B is the ratio? Every time? Seems like it. Every time. Okay? So what effect does B have on the table? What effect does B have on the table? It's the ratio. Okay? Yes, sir.
Does that mean that A is the y-intercept?
Yes, what's another way we can say that? Where does A show up in the table? It's the y value when? x equals 0. It's the y value when x equals 0, which we also know is the y-intercept. Good job. Okay? So let's get those. I know we put it in words on the front. Let's get it on words on this page so that we have it to work with here. Okay? For functions in the form y equals a times b to the x, a is the y-intercept. I'm also going to put something we haven't talked about yet. It's a starting value. Think about the table. This table right here. If we're measuring stuff, where do we usually start? 0. Don't we usually start at 0 and then go like 1 foot, 2 foot, 3 foot, or 1 person, 2 persons, 3 persons, or something like that, right? But we start with 0. So wouldn't that value right there be our starting y value? Right? Okay, so that's how I want you to think about that for now. So we're going to call it our starting value. B is the ratio. It's also the base of the exponent. Sadie, would you shut the door? Thank you. Look at the tables real quick. Because see, this is asking me when the y values are increasing and y values are decreasing. Did we even notice that? Did you notice? You did? In some of the tables, the y values are increasing. What's happening here? Increasing. What's happening here? Decreasing in here. And decreasing in. What makes them increase versus decrease? Decreases is a decimal. That's a good starting point, but not quite where we want to get to. Because isn't 1.5 a decimal? Is that what I meant? Is that what she meant? So when is it increasing? When b is greater than 1. That's very good. Okay? So when is it decreasing then? When it's less than 1? Negative 4 is less than 1. Do you mean that? Very good. 0 is less than b is less than 1. Okay? Well, look at this example right down here. What if b was 1? We didn't put an equal sign on either one of those, did we? Well, let's think about y. Okay, if x is 0, what's 1 at the 0 power? 1 times 4. 4, okay? What's 1 to the first power? 1 times 4. 4. What's 1 to the second power? 1 times 4. 4. And 1 to the third power? Still 1 times 4 is that an exponential function? No, it's a line. Okay? So what if b was equal to 1? Sad. We talked about this a minute ago because I said what if b is negative 4, and that's when we corrected ourselves, right? What if it's negative 2? If x is 0, what's negative 2 to the 0 power? 1. 1 times 4. 4. What's negative 2 to the first power? Negative 2. What's negative 2 times 4? Negative 8. What is negative 2 squared? 4 times 4? 16. And what's negative 2 to the third power? Negative 8 times 4? Negative 32. What if b was a negative number? Frown. Why do you think we don't usually use these values for b? Because they make us sad. That's not the real reason. Why don't we use the values for b? Because it doesn't make an exponential function. Okay? Look at problem number 7. How is problem number 7 different than any of the ones we did on the other page? It's backwards, isn't it? Here, I gave you the equation, asked for the A and B, the ratio, and the table. Here, I gave you the table and asked for the ratio, A and B, and the equation. It's just backwards, right? Can we do it backwards? Yeah. What can you tell me already? Yeah, A is 5, isn't it? A is 5. What is 20 divided by 5? 4. What is 80 divided by 20? 4. What is 320 divided by 80? 4. What is 1280 divided by 320? What's B? 4. What's the equation? 5 times 4 to the x power. You do 8, 9, and 10. You do those. Okay? Any questions? All right, last page. Look at these word problems. Woohoo! Yeah, word problems. I'll do one of them. You do the other one. Do you want to talk about college loans or car values? Okay, before I talk about college loans, do you think you'll have to talk about car loans or car value or college loans anytime in your life? Yeah, you see what I'm talking about? When I was telling you earlier that this shows up? College loans or car value? Which one did you say? College loans. Okay. To help with the cost of tuition, room, and board, you take out a loan for $20,000 for college. You do not have to make any payments on the loan until you leave school. However, the loan amount accumulates interest at the rate of 12% annually. To determine how much you will owe after X years of school, complete the table and the graph. Round the answers to the nearest whole dollar. Okay? So we have this table and we have this graph and we have this equation and then we have 3 questions underneath it. Which one do you think we probably ought to do first? Table's easiest when we have something to go on, right? Like an equation. Okay, so let's talk about the equation. Now, our general form is going to be y equals a times b to the x power, right? And I told you in our definitions, not only is a the y-intercept, but I also called it the starting value. Do we have a starting value for the money that we're borrowing in this problem? $20,000. That is my A. What about my B? It's going to have something to do with 12%, isn't it? Okay? Now, is my table going to be increasing or decreasing? Am I going to be owing more money or am I going to be owing less money? Owing more money. That's the whole idea of a loan, right? Okay? I mean, once you start paying it back, you'll eventually be owing less money, but we're not out of school yet. I think they're expecting us to stay in school for 6 years. Hopefully not, but it happens and that's okay. All right? But here's the deal. If I know my table is increasing, what else do I know about my B value? It has to be greater than 1. When my table is increasing, when my values in my problem are increasing, I'm going to start with one whole, like 100% of what I'm doing and add however much it's changing. Okay? Start with the 1, like 100%, and I add the percent that is changing. Now, I can't just put 12, because that's 12%. And you know when we put it in a math problem, we usually change it to a decimal, right? That's why this doesn't say 100 plus 12. It says 1 plus 0.12. So that is what? 1.12. That is my B value. Does that make sense? Hold on just a second. Are there any questions about where the 20,000 came from? Are there any questions where the 1.12 came from? You got that? Okay. Okay. Can I use that equation to fill in this table? Pretty easily, especially if I have a calculadora. That's how you say calculator in Spanish. Is that correct? Okay. What you got? Spit it out. You okay? Yeah, absolutely. Thought he was about to come out of his chair. Okay. Okay. Control T. Okay. Tab. $20,000 times 1.12 raised to the x power. Okay, so here's the deal. I put it in to look at the graph and copy my graph, and it's broken. Is there anything wrong with my x-axis? It goes to 10. This only goes to 6. It should be fine, right? Oh, well, my graph here goes to 40,000, and my graph here goes to 6. Okay, so nothing's broken. I just haven't gotten it high enough. So I'm going to have to change my window if I actually want to use my graph to graph this. But I could use my table to graph it, couldn't I? Okay, so Control T will take me to my table. 22400, 25088, 28099. Do you agree with that? 28099. Look what it says though. But I also remember I'm running my answers to the whole dollar. Don't forget that. 431470 535247 because that's rounded, and then 6 is 39477. Actually, it's 6. Look why it's 6. It looks like it should be rounded because that says 0.5. But if you look underneath it right there, it already has rounded it to 0.5. So I just needed to leave it alone. Okay. Now I could go and plot these. I'm not going to worry about that right now because I'm worried about time. I'm worried about getting these 3 questions answered for you. You ready? Suppose after graduating college you enter law school. How much would be owed after a total of 8 years in school? I have 2 choices, right? I could get back on my calculator and scroll down to 8. What's my other choice? Yeah, can I put 8 right there in my equation? Either way I do it, I'm going to get 49519. $49,000. Suppose after graduation you decide on medical school. How much would be owed after a total of 12 years in school? Again, same thing. I can scroll down on my calculator, or I can go to my equation and put a 12 in right there, couldn't I? 7791 20. $77,000. What's the domain and range of this problem? What are my x values allowed to be in this problem? Greater than or equal to 0. What are my y values allowed to be in this problem? Why isn't it 0? I started at 20,000. I borrowed 20,000 to start with. Okay? Now, do you have any questions about any of this stuff? Okay? So you have the three problems on this page, 8, 9, and 10 to do, and you have this bottom. While we have just a couple seconds left, let's look really quickly at this equation. As a graduation gift, your grandparents buy you a shiny new car worth $20,000. So that's the same as the one above, right? However, due to wear and tear, the car loses 20% of its value every year. To determine the value of the car after X years, complete the table in the graph. Is our table going to be increasing or decreasing? Decreasing. And if our value is decreasing, that means my B value has to be less than 1, between 0 and 1, right? So my A value is going to be what? 20,000. I agree with that. What is my B value going to be? 0.8. Where did the 0.8 come from? Remember, what did I do up here? I started with 100% that we started with, so the 1, and since I'm losing, that's exactly right. Since I'm losing 20%, I subtract the 0.2 to give me 0.8. Now, what did I forget? The x. Where does it go? Like right here by the 8? Oh, up high. X. Got it? Okay, so finish the table, finish the graph, and finish these questions down here.